Welcome to this episode of our new series, the Patagotitan Chronicles. Let's assume that a few Patagotitans were introduced into the Middle Paleocene of North America and Asia. Paleocene period, 66 to 56 million years ago. In this alternate timeline, the Paleocene epoch marks the first stage of the Cenozoic era, immediately following the end Cretaceous mass extinction. In our alternate timeline, this epoch takes place in a planet that is 11 degrees Celsius warmer than the pre-industrial average, an even warmer climate than in our reality, where the increase was about 8 degrees Celsius during the Paleocene-Eocene thermal maximum, PETM. Patagotitans would quickly speciate and new species would appear. The endless forests of the Paleocene would be quite destroyed, leaving room for other ecosystems like savannas, and new ecosystems would appear. First, let's see if Patagotitan would do well. They would probably manage to survive. Predators would be almost absent, vegetation abundant, and especially the climate. Given the size of these bones, which surpass any of the previously known giant animals, the new dinosaur is the largest known animal that walked on Earth. While many animals should adapt, they will succeed, the grass will spread tens of millions of years earlier, and we have a landscape of North America 5 million years after the introduction of Patagotitan, 0.5 million years before the PETM. An abundant landscape, we have speciation in sauropods. We have a species Unicornus sauropods. Gastornis became a true predator of these large areas. Primates adapted to this new world and succeeded. Sauropods will make their way to Europe. In this case, we have a Paleocene version of the mammoth steppe. Open spaces will promote the growth in size of mammals even earlier than in our timeline. Europe will have small sauropods, much like it was in the late Cretaceous. Like Magosaurus, Europe would be like a kind of Indonesia. Because Asian elephants are true ecosystem engineers, they will increase the biodiversity of the European Paleocene forests. While Asia and North America have massive savanna areas, flora sequoias, palms, and saxifragales become dominant species in savannas and humid forests. Primitive ferns and grasses colonize open areas. Angiosperms continue their rapid expansion, adapting to climate change and frequent fires. Important events, the PETM, Paleocene-Eocene thermal maximum, is more intense, causing a huge ecological shock, massive migrations, regional extinctions, and the rapid emergence of new species. Dinosaurs of the genus Patagotitan unexpectedly influenced the global landscape, creating a transitional era between the Mesozoic and Cenozoic worlds. Multituberculates rival rodents, hindering their early rise. Other parts of the world are affected indirectly because the PETM is much more severe with 11 degrees warmer. Well, whales are still evolving, but they will be toothed whales and very few with fins. The Pleistocene Ice Age could be completely reversed. The Oligocene cooling would be much less severe without massive drying. Antarctica would still be colder, but not freezing like in our world. Ice caps would still develop, but it wouldn't become a desolate desert. In part 2, we will introduce the titans of the Speculative evolution series.